Hi everybody, today we're going to be talking about linear programming, and in our notes our linear programming is actually lesson 3.2, but this lesson is going to kind of go a little bit before 3.2, so you might want to call this pre 3.2 or something like that. But anyway, that's what we're going to be talking about today. I'm just going to work through one example so that we understand some basics, and a lot of this we've already talked about. So in the last video we talked about how sometimes it's helpful if we label R1, R2, R3, and R4. So you might take a second to do that. Then we can go ahead and start graphing. Notice there are no axes here, and the reason for that is because different ones might take different axes. So because I look at my first R1 and R2, I've got x is greater than or equal to 0 and y is greater than or equal to 0. So I can put my axes, because that means only positive numbers. What those two equations mean, or inequalities, is only positive numbers. So I can put my axes in. I'm going to put them in, I'm going to give myself a little bit of space, but basically on the edges like this. All right, so I've got my axes here. I'm going to say if it's x is greater than 0, then this is my R1 right here. And I probably should have left that arrow down there. So this is R1, and then this is R2. And x is greater than 0 means I'm going to shade this way. And y is greater than 0 is this R2, and that means I need to shade this way. It's going to be only things in the positive quadrant here. Now I'm going to go on to my R3. I'm going to start at 3. I'm going to go up 3, right 1. So I start at a y-intercept of 3. I count my slope up 3, right 1, up 3, right 1, up 3, right 1, and so forth. And of course I could go down 3, right 1. Now I need to get my straight edge and connect those. If you are not using a straight edge, this is actually going to be much more difficult, because when you use a straight edge, it helps to see exactly where things hit each other. And so I'm going to go ahead and label that R3. It says less than or equal to, and its y is less than or equal to, so we've talked about how that means below the axis. And as I color this below the axis, I actually do not need to shade this little triangle over here, and the reason is because it can't be there. It has to be in the positives. We talked about that. X has to be greater than 0, so it's not that piece, but it's just everything up until that, okay? Last one, R4, is going to start at 7, and then it goes down 1, right 1, down 1, right 1, down 1, right 1. So there is my R4, and it says less than, and so that means I go below the line because it's y equals. So I'm going to go below the line. So my shaded area is going to be this trapezoid here. This is going to be the area that's shaded. When you get these kind of drawings, you want to make sure that it's clear what the shaded area is in the end. And so when I started this off the other day, I said, don't shade real dark at the beginning, but as you go, it's going to get darker and darker and darker, and by the end, anyone who looks at this should be able to see, oh, that's the area you're talking about. And in the other video, I also mentioned that, I'm not going to take the time to erase, but if you need to, you might need to erase some of this stuff so that it's a little bit more clear that that's not the shaded area, that only this piece is the shaded area, okay? Now, I don't think it's necessarily to erase all that as long as you color it darkly, but the reader, that is me, when I look at your paper, I need to be able to see what is the shaded area. And even if it's messy like this, I can still tell this is the shaded area. Now, the next thing we need to do is also like we did in the last video, we need to find the intersection points. So we have an intersection here and here. Now, over here, remember I said it's not in that little corner, but there's an intersection there and an intersection there. And so I need to find what those 4 vertices are. And I can tell you that space is going to get a little bit tight, so I'm going to write my vertices over here. I know that I have a vertex at 0, 0. I have another one I have to count, but that is 7, 0. I have one up here at 0, 3. That's a 0. And lastly, I have this one up here, and that is at the point 1, 6. Now, luckily, I did not have any fractions. I think on this worksheet, if I remember, I don't think there's any fractions on the rest of this worksheet. But this video is just going to go over this first example. Okay, now, That's not new. We've learned that before. The next part that's new is the question says to maximize this equation for the constraints in the above system. What that means is we are going to be doing some problems where we're going to try to maximize or minimize certain situations. And as it turns out, the maximum or minimum point that will do the best job of maximizing or minimizing will always be a vertex. It's not going to be anything inside. It's always just the vertices that make the best sense as far as maximizing or minimizing. So what I need to do now is I'm going to plug these numbers in to this function. So I have this function. I'm going to plug each of these in. Let me show you what I mean. So I'm going to say that P is equal to 10 times, and I'll just use the first one, 0, 0. 10 times 0 plus 16 times 0. Well, that's easy. That's 0 plus 0 is 0. Probably not going to be the max. All right, I'm going to go to my next one. My next one is 7, 0. So I'll take 10 times 7 plus 16 times 0. Well, 10 times 7 is 70, and that's 0, so that's 70. Definitely getting higher, but I want to find my maximum, so I have to plug all of them in and see. The third one, P is 10 times 0 plus 16 times 3. Well, that's 0, and this is 48, so better than 0, but not quite as high as 70. I need to do my last one and see if it comes up any higher than the other one did. Remember how I said this is taking a lot of space, so these numbers that I'm plugging in here do not necessarily relate to these equations. It relates to this equation down here. All right, so I was plugging in 1, 6. So I plugged in my 1, and now I need to plug in my 6. I might need my calculator. I know that this is 10, and then this, when I multiply this, that's going to come out to be 96. And if I add those together, I get 106. That's my maximum value, isn't it? It asked to maximize. When I give my answer, I'm going to say that the 0.16 gives a maximum value of 106. All right, right now these don't have any context to them. We are going to get to a point where we're putting in some word problems, and it'll make a little bit more sense because you'll have context. For now, all you need to know is you have to graph, shade, find the vertices, and each vertex then needs to be plugged in to this maximizing function. That's what this is called. It's called a maximizing function, to see which number will give us, which point will give us the actual maximum value, and what is that maximum value. And in this case, it was the 0.16 that gave a max value of 106. We will work on the rest of this worksheet in class tomorrow.